Jerusalem College of Engineering, an autonomous institution located in the heart of Chennai city, the best engineering college in Chennai, NAC A grade accredited and NBA accredited institution, counseling code 1307. Join at JCE to equip and explore to be industry ready. Test cases, okay. So among 65 test cases executed, okay, how many test cases passed? Only 30 test cases are passed, and 26 test cases are failed, and 9 test cases are blocked. Okay, so if we add this 30, 26 and 29 will be getting 65. Okay, so the total number of test case executed is 65. So I am recording the entire lecture so that others can be able to view also. So kindly encourage others to join because now only 31 students are there. Okay. So let me recap what we have seen so far. We started our presentation with the formal definition for software metrics. Then we moved to software metrics. Then we have seen the test metrics. Then we have seen software test measurements. Now after that we have seen the difference between measurement and metrics. Then we move to software metrics life cycle, and we have seen two different types of manual test metrics, base metrics and calculated metrics. We have seen the difference between base metrics and calculated metrics. Now we have arrived at the process metrics. Okay. Software test metrics are used in the process of test preparation and test execution phase of software development, software testing life cycle. So these are all the various the sample metrics for software test metrics for the automated process. Software test case preparation productivity, test design coverage, test execution productivity, test execution coverage, test case passed, test cases failed, test cases blocked. And let us see the various metrics coming under product metrics. And software test metrics are used in the process of defect analysis phase of software testing life cycle. So the examples are error discovery rate, defect fix rate, defect density, defect leakage, defect removal efficiency. Now we will see various software testing metrics and how we can calculate. We will see various formulas which are helping us to calculate the metrics. Okay, this particular slides gives an overview of the base metrics. Okay, these are all various metrics will be provided for this particular case study. Example, number of requirements is 5 and the average number of test cases returned per requirement 20. So if average number of test cases returned per requirement is 20, then for 5 requirements it is 100. The total number of test cases I have returned is 100. Okay. So number of requirements 5. Okay, so can you able to tell an example requirement? Any one of you can unmute and a requirement. Tell one example for requirement for banking application. I have given a lot of examples now during our class. One of the requirement for banking example. Any one of you can you unmute and speak? Any response?
Yes, sir.
Yeah, please tell me. 1 minute. Can you tell any one of the examples with respect to banking application, the requirement? Who responded? Okay. See, the opening an account is a requirement. Okay. So for that, opening an account, I can write a number of test cases. Okay. So here in the examples, they have given that 20 requirements or 20 case test cases are generated for each requirement. So the total number of test cases returned for all the 5 requirements at 100. Okay. Then now the total number of test cases executed among 100 executed among 100 test cases, I have executed only 65 test cases. Okay. So among 65 test cases executed, okay, how many test cases passed? Only 30 test cases are passed, and 26 test cases are failed, and 9 test cases are blocked. Okay. So if you add this 30, 26, and 29, will be getting 65. Okay. So the total number of test case executed is 65, and the total number of test cases I have returned for this particular task is 100. Okay. So among the 65 test cases I have executed, 30 test cases are passed, 26 test cases are failed, and 9 test cases are blocked. Okay. So how many test cases I have not executed? The total number of test cases generated are 100. Total number of test cases executed are 65. So the number of test cases unexecuted is 35. Okay. So among the 65 test cases I have executed, I have identified 30 defects. So total number of defects identified is 30. Among 30, critical defects count are 6, and high defects count are 10, and medium defects count are 6, and low defects count are 8. Okay, so if you add all these things, you'll be getting. So why these data are very essential? Okay, several times I 100% perfection. We cannot achieve 100% of percentage execution perfection in any of your tasks. Okay, sometimes we have to sail along with some kind of risk. Okay, so we have to give priority. So for the critical defects, for high defects, and sometimes for medium defects. Okay, so you need not waste your time, waste your resources for dealing with low defects. So we have to categorize the defects, okay, which can be addressed first. Okay, so here critical number of defects count is 6. I have identified 10 defects have high priority, and medium priority are 6, and low priority. Okay, as I mentioned earlier, these 13 metrics are base metrics. Okay, so now what I'm going to do is I'm going to explain some of the calculated metrics. Okay, so when you go for calculated metrics, we have to define a formula and use the data which we have arrived in the base metrics. The first matrix is percentage test cases executed. This matrix is used to obtain the execution status of the test case in terms of percentage. Okay, so if I want to calculate the percentage test cases executed, I know the number of test cases I have written and the number of test cases I have executed. So the formula says number of test cases executed divided by number of test cases written into 100. So the number of test cases executed is 65. I have taken this 65, this data from the base matrix. Okay, total number of test cases executed, it's already given. And total number of test cases written, okay, it's also there. Total number of test cases written for all the 5 requirement is 100. So 65 divided by 100 into 100 is equal to 65%. The next matrix is percentage of test cases not executed. Okay, as we have calculated percentage of test cases executed, we can calculate percentage of test cases not executed. Okay, the formula is percentage test cases not executed is equal to number of test cases not executed divided by total number of test cases returned into 100. Okay, so I got this value from the base matrix. Okay, here it is very clear that number of test cases unexecuted is 35. Okay, I have taken this value from the base matrix, and this calculated matrix percentage of test cases not executed. Okay, so as a test lead, as a test manager, I have to generate a report. Okay, from these two calculated metrics, I can generate a report in the form of a chart. Either I can go for pie chart, I can go for bar chart. Okay, this is a pictorial representation of the calculated metrics which we have derived now. Okay, so in this way you have to present it to your management. And similarly, percentage test cases passed. You know that number of test cases passed, and you know the number of test cases executed. Okay, so here when you calculate it, you have to consider the number of test cases executed. Okay, don't be confused with the total number of test cases generated. Okay, so total number of test cases passed divided by total number of test cases executed into 100. So both values are available in the base matrix. The total number of test cases passed is 30. Number of test cases, total number of test cases executed is 65. So the pass percentage is 46%. Similarly, I can calculate pass percentage of test cases failed. Okay, so the formula used for pass percentage of test case failed is number of test cases failed divided by total number of test cases executed. Again, I insist, don't be confused with the total number of test cases generated here into 100. Okay, so the total number of test cases failed is 26 divided by total number of test cases executed 65, and 100 is equal to 40%. And blocked, okay, some of the test cases has not been considered for execution. So this matrix is used to obtain the blocked percentage of executed test cases. And detailed report can be submitted by specifying the actual reason for blocking the test cases. While submitting this, we have to justify the reason for blocking the particular test cases. Percentage of test cases blocked is equal to number of test cases blocked divided by total number of test cases executed into 100. So I'll be getting the value 14%. Okay, so with the help of the total number of test cases blocked, the total number of test cases failed, the total number of test cases passed, I can generate a pie chart or a bar chart for the report purpose. And the density, defect density, okay, another important matrix, defect density. So it is calculated with the help of number of defects identified divided by size. Okay, here the size is nothing but number of requirements. Okay, so number of defects identified is 30. Okay, so defect density is it is assumed that 6 defects per requirement. Okay, defect density is calculated as the number of defects identified per requirement. Similarly, defect density can be calculated as a number of defects identified per 100 lines of code. Okay, because we have considered the number of requirements. Our given data, base data is sometimes instead of number of defects, sometimes they may give 100 lines of code. For each 100 lines of code, how many defects are identified? The number of defects identified per module, etc. Okay, these are all various things, but for our case study, the given base data is number of requirement. Okay, so similar the formula. So the formula for the defect density is number of defects identified divided by size is equal to 30 divided by is equal to 6. Defect removal efficiency. Defect removal efficiency, number of defects found during quality assurance testing divided by number of defects found during quality assurance testing plus number of defects found by end user. Okay, end user, it is during the alpha beta testing. Okay, into 100. Defect removal efficiency is used to identify the test effectiveness of the system. Okay, so during development and quality testing, 100 defects are identified. During alpha and beta testing, 40 defects are identified. So we can put this value, you'll be getting the 75% as defect removal efficiency. Now the defect leakage. Okay, so defect leakage is a matrix which is used to identify the efficiency of quality assurance testing. That is, how many defects are missed or slipped during the quality assurance testing. Okay, so there is no guarantee that we will be identifying 100% of defects. Okay, even if you be a smart tester, you cannot say that I can generate 100% test cases. Okay, it's all depends on how smart we are in generating test cases. Okay, so defects will be identified based on the number of test cases we have generated. So we cannot give any guarantee that I have identified all the defects. Okay. So in that case, we have to identify the defect leakage. Defect leakage is the matrix which is used to identify the efficiency of quality assurance testing. Then how many defects are missed or slipped during the quality assurance testing. Okay. Defect leakage is equal to number of defects found in user analysis test divided by number of defects found in quality assurance testing into 100. During development and quality assurance testing, is 100 defects are identified. During alpha beta testing, 40 defects are identified. So defect leakage is equal to 40 divided by 100 into 100 is equal to 40%. And defects by priority. This metric is used to identify the number of defects identified based on the severity or the priority of the defects, which is used to decide the quality of the software. Here, the percentage of critical defects is equal to already in the base matrix, the number of critical defects are identified. Okay. So similarly, we can after identifying this as a 20%, we can able to see the vulnerability involved in the software development process. Okay. Accordingly, we can change the infrastructure. Accordingly, we can change the budget. Okay. So it helps the management to take proper decision. So critical defects equal to number of defects, critical defects identified divided by total number of defects identified into 100. From the data available in the above table, percentage of critical defects is equal to 6 divided by here. 6 defects are identified as critical defects among the 30 defects identified. Okay. While 65 test cases are executed, into 100 is equal to 20%. So similarly, we can calculate the percentage of high defects. Okay, the same formula can be applied here. So we have the value 33.33%, and percentage of medium defects, it is 20%, and percentage of low defects is 27. Okay. So what we can do is, if the percentage of low defects, since the percentage of low defects is 27, we can leave it. Other defects can be rectified. Okay. So the critical defects, high defects, and medium defects must be rectified. And this is a pictorial representation for the critical defects count, high defects count, low defects count, and medium defects count. The single picture gives the meaningful information to the management that 20% are critical defects. We have to deal it immediately, and the 33% high defects, we have to address it without much delay, and low defects is 27%, and median defects 20%. Okay. So the critical defects, high defects, if possible median defects, must be addressed before you move to the next process, and we can go along with this 27% of low defects, which will not harm your product much. Okay. And process metrics, software metrics used in the process of test preparation and test execution phases of software test life cycle. Okay. Test case preparation productivity, it is used to calculate the number of test cases prepared and the effort spent for the preparation of test cases. Here, the test case preparation productivity is equal to number of test cases divided by effort spent for the test case preparation. So here the values are given, total number of test cases, if it is 240, and the effort spent for the test case preparation is 10 hours. Now the test case preparation productivity is 24 test cases per hour. And test design coverage, it helps to measure the percentage of test case coverage against the number of requirements. Here, the test design coverage is equal to total number of requirements mapped to test cases divided by total number of requirements into 100. So all the values are given. The total number of requirements is 100, and the total number of requirements mapped to test cases is 98, and the test design coverage is 98%. Similarly, test execution productivity is another metrics coming under process metrics. It determines the number of test cases that can be executed per hour. Okay, how many test cases I can execute in an hour. Okay, number of test cases executed divided by effort spent for execution of test cases. Here the values are given. Total number of, if the total number of test cases executed are 180 and the effort spent for execution of 10 hours, then test execution productivity is nothing but 18 test cases per hour. Test execution coverage, it is to measure the number of test case executed against the number of test cases planned. Test execution coverage is equal to number of test cases executed divided by total number of test cases planned to execute into 100. So the values are given. Total number of test cases planned to execute is 240. And if the total number of test cases executed is 160, then total test execution coverage is 75%. Okay. So, and these are all the books you have to refer. I have prepared these slides from two books. One is Practical Software Testing, Ian Burston, and Software Testing Principles and Practices, written by Gopal Swami Ramesh and Srinivas Desika. Okay. So, for further information, you can contact, you can refer these two books. Okay. If you have any doubt, can you switch on your camera? I just want to take a snap video. My request, don't go out now. Okay, don't jump. Similarly, others, please switch on your camera so it helps me to take a photo. It's just for proof only. Very good, David. Okay. Can others? I'll take a snap and go. I'll wind up.